Welcome to the next part. So where we last left off is that we were able to find the distance of A and the distance of B. One quick thing I want to change, just because it might get a little bit confusing. I got a little bit confused. We're naming this point A and point B. That's fine. Let's just do point 1 and point 2, just because that way the name we're doing on code or when we're drawing it out is the same. So I'm just going to quickly change all point A, point B, and then similarly for like C, instead of calling it C, let's call it point 3. We'll call it P3x, and then we'll call it P3y. Okay, and something that might help us so that we just get it done once and for all right at the beginning is we can just make variables for everything. So let's say let P1x, we can make that, we need to change this to point 1, point 2, P1x is equal to point 1 dot x, let P2x, that's equal to point 2 dot x, and we can say let P1y is equal to point 1 dot y. We're just doing this just so we can more easily refer to them, and then we're going to say let P2y is equal to point 2 dot y. Okay, so these are our points then, right? Point 1, point 2, point 3. We have now lost this because we're looking at these ones, so let's quickly change this up. So point A dot x is going to be P1x, P1y, then P2x, P2y. And then this one is P3x, P3y. Cool. Just something a little bit more cleaner, easier to read, easier to understand. And we're back to our normal triangle. We do have an error. Let's see if we can't see what that is. Point A is not defined. Yes, in order to actually get that, we now need to say, okay, so now the distance is going from point 1x, so P1x, to P3x. And point that one, we're looking at point 2y to P3y. Okay, cool. Well, we're back where we started, just slightly more readable names. So what I now want to look at is the squares that we draw on the sides of the triangle. And we'll see why we're doing that and why that's relevant to Pythagoras. So I'm going to go ahead and bring up a whiteboard again. And we know we have these 3 points over here, right? Point 1, point 2, point 3. The goal for us is to find this distance from point 1 to point 2. Point 3 we constructed based on point 1 and point 2. And we made this right angle triangle. That's what happened. And now what we know is if we have A, B, and C, we know that we're saying we're saying that Pythag is saying that c squared is equal to a squared plus b squared. Now, whenever we're multiplying something, whenever we're squaring something, it's very useful to think of it as an area. To think of when you're multiplying one thing by another, you are really finding the area of a shape by doing so. So when we're saying a squared, let's take an example of a rectangle. If I have a rectangle here, like this, and I say that this is A, let's say that this is the width and this is the height. We know that the area of this is WH. Now, when we say A squared over here, we're simply saying, okay, we're going to make a rectangle, or a square rather, whose length and width are the same. So that's A, and now our area is equal to A squared. So what we're really saying when we say c squared is equal to a squared plus b squared, we're saying the area of the square on the sides of this. So if I draw a square, I'll do this in another color. If I draw a square over here of length side A, so that is A and then that is A. And I draw another square over here of B. So that is B and then that is B. Okay? What it's saying is then the square over here, the area of the square on top of C, as I go over everything, make a bit more space. The area of that, this area over here, is equal to this area plus this area. Let's do a different color. That's really what we're saying. That's what c squared is equal to a squared plus b squared is saying. And so we should be able to visualize that then using the squares. And that's what we're trying to do. So now that we have that kind of background set up and why we're going about doing it, let's have a look at taking it a step further. So we actually want to go ahead and draw these squares on the side here. Let's go back. I don't know why I raised everything. Okay, so we know with P5, in order to draw a rectangle, we need to specify the top left coordinate, and then the width and the height. And we know that's B and B. And we know that this point over here is simply 0.3, so that's P3x and P3y. So let's put that in. So I can come here and I can say rect at P3x, P3y. And then I know that this one is of side B. So it's going to be B for width, B for height. And now when we get it, we can see we get our rectangle over here, or our square rather. And so the area of the square is just the length, each side is this length, B. Okay, and we can make this a little bit nicer. Let's put a fill into it. Let's fill it red. Okay, now let's look at the other one. So if we're now wanting to get a square to sit over here, we know we need to specify the top left corner. So that means we actually need to specify here. So let's look at how we can do that. If we need to specify this point over here, and this is point 1, right? And there we have x1, y1. Then what is this coordinate? Well, we know we're going up by a. So we're not changing x, so our x is staying the same, but our y is going up. And because our y usually increases going down, or the way we currently have it set up, this y coordinate is going to be y1 minus a. Okay, let's put that into code. So we can say rect, and we're looking at p1x and p1y minus a, and then a. And when that should save now, we should get perfect, okay? And we have our two squares. All right, we can put that in a different color. Make it green. And that is where I think we will end for today of these, the areas of these squares. I will see you in the next part.